guess the manufacturer, you can zoom in. But does anybody know what the state of charge is? We don't know. Is there a hazard to a firefighter if they fall on one of those? Firefighting operations. So in firefighting operations, if one of these packs, I'm going to call thermal runaway, we're in a smart group, I'm going to call it a battery having a bad day. That is my stick. It's just, I can't tell you why, I don't know what it's doing, but if one of those batteries is having a bad day, what do we expect the building to do? And how, in US fire codes and in the international codes, firefighter safety is one of its priorities. And so how do I keep my firefighters safe? So we would assume building fire protection, early notification with fire alarms, state of charge under 30%, we're pretty much good, except we need one more thing, that's emergency response plan. How do I solve this issue if one of those battery packs is having a bad day? And I think most of us would say that battery pack needs to get outside. Well, how do I do that? You know, it doesn't take far to find Factory Zero here in Detroit. They've had about 3 incidents, and that has been one of the biggest difficulties is the coordination between local and the fire department and how do we get the battery pack outside so it can finish having its bad day somewhere else. Now there is one more spectrum that tends to fall in, and this is DIY. So everybody knows YouTube? Okay, you can become YouTube certified. Okay, so just watch enough YouTube videos and you can make your own home energy storage system. That's what this was. This person lost their house. They bought their photovoltaic from IKEA. They bought an inverter off Amazon, and they bought as many 18650 cells as somebody would ship. The first day they turned the inverter on, house caught on fire. They lost their whole house because it's sensitive. The question becomes, how do we educate, how do we bring that knowledge base up? It's drastically different as we start to move along. And so there's some basic principles that all of our fire codes do. We want to keep fires small. We don't want them to be spreading. And we keep fires small by fire suppression, early notification, firewall separations, door closure devices, all of those things. And that is typical regardless of commodity. These doors are closing. There are fire sprinklers in here. We do not want smoke mitigating if there is a fire in this space out into our common lot. That is a very common principle that happens in a lot of our buildings. And so we took a lot of these and came and said, this is a unique issue that I think a lot of people, we think that the issue in many cases is EV packs and EVs and ESS and the finished product. Our firefighters are experiencing it in very unique ways. This is a facility designed to support automotive. Their robot had a bad day. And it was a welding robot who had a bad day. And it welded across the top of a live battery pack. Causing, right? If you take a welder and put it across the battery, is it going to catch on fire or going thermal runaway? Yeah. Most of us are going to go, yes. And so in this case, 6 firefighters responded to this building, and that is a battery, that is the biggest commercially available battery pack. I'll let you guess the manufacturer. How much does that weigh? 1,400, 1,500 pounds, 2,000 pounds? How many people does it take to get off a table from this to get it outside? Because that's really how they're going to solve this issue. They can let the sprinklers run, they can let the detection run, but arguably they've got to get this. Does this look like a crazy fire? Does it look like an annoying fire? And so how do our codes and standards handle this? Because no CEO wants that left in their building and let it just run its course for 4 hours. They're going to want that outside, so it's separated. We can clean up our buildings and go back.
Core competencies in all of our use groups, and use groups are how we use buildings. This is an assembly use group. I think all of us would agree that this is different than an industrial process like an auto manufacturing. Completely different, and there's different habits. And this is a great case. This is an EV being worked on. Do we expect our automotive facilities to change their safeguards when they go from working on combustion vehicles to EVs? Let me switch up the question. If you change from combustion vehicles to hydrogen, do you need to change the life safety equipment in your building? You do. If I go from combustion to CNG, do I need to change? I do. The question is, do I need to change when I go from working on combustion vehicles, ICE, to EVs? Do I need to change? And so codes and standards were trying to say, okay, yes, we think you should. How do you handle it, and what are some of the safeguards? So these core principles on the left are really what our codes were trying to address. First, what do we classify these buildings as? And you're going to hear us talk about use group because that's a really important part. Some things that were happening in communities. Mike O'Brien's big battery shop. I make your flying homes. Anybody here besides me driving home? 2 of us. You're all getting on an airplane in the next day or 2, correct? Okay, look out your window. What is pushing your airplane? Is it gas or battery? What is moving your luggage? Is it gas or battery? And so we have this rapid change, and Mark could make money. And so he would take the scooter into his residential occupancy, plug it in, and in the app, he's making money. We don't have to pay people. The app works great. Cases, and there's a lot of vendors that are now available for how we charge these products and devices inside. And there's a lot of best practices that have been rapidly evolving. But again, those core principles that I had a couple slides. What happens with our fire hazard and stored energy when we start stacking them? What happens when we put them on boats, ships, bring them into port? And so we're seeing a lot of very rapid changes in those spaces that are probably challenging some of our assumptions up to this point. And so we have a lot of work that will continue on in all of our codes and standards as we learn to address them.